Okay, so I wanted to go over 2.4, which is called the graph of functions. And so they wanted you to watch that video that's on that one section. So I'm not going to watch the video with you because you can watch that on your own. And then it says, and then identify what is happening at each point of the graph, which I think you can do this part on your own in terms of where Mark is in terms of time and distance and like what's actually happening in that whole situation. So thinking about Mark walking away from his house and then he stops to do a couple things, and what does that actually mean in the graph? Okay, so you're going to do that on your own. The second part is now fill in the blanks and circle the correct words to describe the change of the graph. So straight sections on the graph. Okay, so when they're talking about that part, or anything that is straight, okay, no curves, no circles, no, like that, represents linear relationships. So I'm going to write linear, right? And then sections of the graph that are not straight represents non-linear relationships. Okay, and show a rate of change that is not constant, right? Oops, I did not circle this part here. So because it's linear, then it's constant. Because it's not linear, then it's not constant, right? For a graph showing a car's distance over time, the rate of change is the car's speed, like how fast it's going. And that makes sense, right? Because it's distance over time, right? That's what you describe speed as, right? Miles per hour. And the rate of change is shown on the graph as an upward curve. When the car's speed is constant, the rate of change is shown as a line. Some people say straight line, but really all lines are straight. So I'm not going to put straight line because that's like redundant. Okay, so fill in the blanks and complete the steps to sketch the graph of a trip that has 3 parts. So, so Sarah walks to Natalie's house. Sarah waits for Natalie, and Sarah and Natalie walk back to their house. Okay, so they don't give us a lot of like time, how long it takes them, or distance. So for here, your graph may look different than mine, especially because here there's no like units of time, not like, there were not units of time here as well. Okay, so here we're just interested in looking at what does that actually look like. So for this one, let's say I would go like this. So I go maybe something like this. And so this would represent Sarah walks to Natalie's house. And so here, notice this is the distance from Sarah's house. So first she starts out at home and she starts walking. Now notice she's walking at a constant rate to Natalie's house. And then she gets to Natalie's house, right? And then so now Sarah's waiting. I don't know how long she's waiting. Maybe she's waiting 5 minutes, 10 minutes, 15 minutes. And maybe they're Natalie's getting her bike and whatever, and maybe not bike because they're walking back. And then now they're walking back to Sarah's house, and maybe because they're talking along the way, it's going to take them a little bit longer to walk back to Sarah's house. So notice here the pace at which Sarah's walking to, maybe she's excited. And then here, because, the girls are looking at the flowers or whatever the case might be, it's taking them a little bit longer. And you can kind of see that because the slope is a little bit less steep than this one. So here, the variable for the y-axis is the distance from Sarah's house. So I'm literally going to write that out. Distance from Sarah's house. Okay. So the variable for the y-axis is time. And we could see that because it says right here, time. So we graph the first part and it says, start at the origin. This is the point where Sarah leaves from her house and it's 0 distance. and 0 time. And then assume that Sarah walks at a constant pace and draw a segment to, and we did that already. We went boop, right? And then this one says graph the second part of the trip. Sarah waits at Natalie's house. So Sarah's distance from her house doesn't change, right? And the reason why it doesn't change is because time is passing, but her distance from her house is not, because she's kind of like, she is at Natalie's house, right? So that's why this distance here doesn't change. The distance from her house is still the same, right? And then it says, graph the third part. Sarah and Natalie walk back to Sarah's house. As Sarah walks back home, the distance of her house will decrease, right? Because, you know, the distance is, I don't know, maybe like 4 houses. Maybe she just lives literally down the street. So she's at 4 houses, and as they walk back, then she's 3 houses, then 2 houses. It's literally decreasing. When Sarah's back home, her distance will be 0. Okay. And then draw the segment. We already did that. A graph of the distance over time may include straight line sections and curved sections. Explain why a graph of a real world scenario may include curved sections. So this is right here. This represents a constant pace right here. Constant pace. So when Sarah leaves her house, she's walking at a constant pace, right? So maybe like if you look, you know, graphed another person's graph, like I'm just going to use a different color, and let's pretend this person is jogging. And so when you're jogging, you don't start out at the same exact pace that you're going to jog for. So there's like this little kind of like ramping up to the speed. So that might look like this. I don't know, just pretending. And then once she's at the speed that you want, then you have this, then it might look like a little bit more straight, right? So at first you go out there and you're walking because maybe you need to warm up, and then you speed up a little bit, and then boom, you hit your pace, and your pace is a little bit more straight, right? A little bit more constant. Okay, next part. It says, identify 2 scenarios that could be represented by each graph. Include one that is not in the study. Okay, so you saw a bunch of different, or you may have seen a bunch of different things. So they want you to come up with, you know, a different scenario for each of these. So for this one, I think about, like, let's just say, I don't know, like maybe this is the level of water in a bathtub. So there's some water in the bathtub and it's really, really hot. So then what I'm going to do is I'm going to cool that bath water down. So I turn on the faucet and it turns on and the water level is filling up. So for this one, I'm saying that the x-axis is time and the y-axis is water level, right? So it's too hot, and so I start filling it up with a little bit not as hot water, maybe like warm water, to cool it down a little bit. And notice that the water level is rising, and then I'm going to stop because, you know, I can't fill it up too much, because once, you know, my daughter gets in, or whoever I'm making the bath for, that gets in, it's gonna, you know, the water is gonna get displaced and it's getting even higher. So this is the water level of me filling up a bathtub. Okay, there's other scenarios that you can possibly use. You can think about, like, maybe you are making something. I don't know what you're making, but this would be time, and maybe it's like you're, you know, maybe you're drawing, right? And this is the progress. This y-axis would be the progress of your drawing. So one day you take, I don't know, 2.5 hours and you're just working on it, and you're making progress. And then you stop for the day and notice how your progress is paused. So while the drawing is just sitting there, it's not going to be making progress on its own. You walked away from the drawing for a second, or you're away for your drawing to go eat dinner, or whatever the case might be. Um, so, um, so this, a picture here, this is a curve that you will learn about in high school. And there's a lot of different scenarios that you can use for this, but let's pretend that you are on a Ferris wheel, right? And this here is the distance from the ground, and this is time. So you start off and you get on the ride, and you get higher from the ground, and then you're at the top, and then all of a sudden you go around that curve, and then you go to the lower parts of the ground, like you are approaching the ground, and then you just continue. Another one of these is people talk about the sun's movement as this, right? The sun rises, and then this is noon, right? This is noontime, and then the sun sets, and then we can't really see the sun at the nighttime, and then it just continues. So there's a lot of curves. These are called waves. Okay. And that's pretty much it for our lesson. Hope that made sense. Bye.